Hello everyone. Now we're in the chapter 3, which is in the k-mapping section. A k-map is a diagram which is made of sequence with each of the sequence represented one minterm of the function that be minimized. Since any Boolean function can be expressed as the sum of the minterm is following the Boolean function recognized graphically in the map and enclosed those sequence with included the functions. In easy section you can say that kmap is for mapping a Boolean function. These functions are known as kmap because in this section you can see that m1 plus m2 and there are some conditions. By solving these conditions we can generate those types of math which are known as k-maps. In this A section we have M0 to M3 which have 4 quadrants. In this section we divided them by X and Y. This is for the Y section and this is for the X section. That is why we have generated in this M0 section we have X dash Y dash, M1 for X dash Y, M2 for X Y dash and M3 for XY. That's the reason we are now having the XY which is situated in the M3 section. From this diagram we can easily say that XY, for this XY we can see the M3 which value is 1 and we now want to generate the X plus Y. To generate the X plus Y by this formula we can easily see that X plus Y equals to X dash Y plus XY dash then XY. That is why in this diagram we can see that X dash Y is situated in this section, XY dash which is situated in M2 section and XY which is situated in M3 section. That's why those three sections are getting the value 1. That's how the k-map works. Now here are we in the 3 variable k-mapping. In this section we have 3 variables. Because we have 3 variables so we'll get the value 2 to the power 3 which is 8, and in this section we have 2 variables where 2 to the power 4 we have 4 quadrants, and in this section we have 2 to the power 3 that means 8 quadrants which are started from M0 to M6. In the section M0 is for X dash Y dash Z dash, and moving on lastly we have the X, Y and Z dash. In the section of X we have the 0 section and the 1 section. In the 0 section all the value of X is added with bar. Here in the 0 section we have X bar, X bar, X bar and X bar. In the 1 section we have the general X, X, X and X. If you are in the 0, 0 section of YZ then you have Y bar and Z bar, Y bar, Z bar. In this section you have Y bar Z, then Y bar Z. 1 1 means X Y Z, and here we have Y Z again. In this section 1 0 we have Y Z bar and Y Z bar. Point to be noted that here we have first the 0 value, then 1, but instead of 2 we have this 3 in section of 2 and then the value is 2 of binary section. So the sequence would be 0, 1, 3 then 2, which is specially used for the 3 variable k-mapping. We can solve this section by this k-mapping section. Now we are in the 4 variable k-mapping. In this section we will have 2 to the power 4, that means total 16 quadrants which starts from M0 and goes up to M15. In this section we are divided into M0, M1 then M3 which we got from 3 variables, then M2, then again M4, M5, M7, then the M6. Then we have the M12, M13, M15, then M14, and lastly the M8, M9, M11 and M10. This sequence should be remembered for k-mapping. And here we divided this section by, in this section we have w and x, and in this section we have y and z. 0, 1, 3 and 2, then again 0, 1, 3 and 2. That's how we divided the k-mapping section, and after generating this k-map we can easily solve our mathematical functions. Don't care condition. A don't care condition is a mean term which combines a variable whose logical value is not specified. Don't care condition means it doesn't care about any condition and goes what it wants to do. Now, the NAND circuit. The NAND circuit is nothing but a NOT gate is in front of the AND gate. The AND gate does the multiplication work. Here in this section we have this one is a NOT gate, and this NOT gate is connected with an AND gate. That is why it is known as NAND gate. The work of NAND gate can be done by those types of. In this section we have an inversion because we are having x, y, z, and the result will be x, y, z, but we are having NOT gate in front of the AND gate. That is why we are giving the value AND inverse, which is by x, y, z and total bar. Here we have the invert or by having, here we are getting the value x bar because here is a NOT gate, here is a NOT gate, and here is a NOT gate. That is why you are getting x bar plus y bar plus z bar. That will become xyz total bar. So that's the reason we can say that those two diagrams are same working. Now we are in the chapter 4, which is combinational logic. In this combinational logic circuit we have some n inputs and m outputs. In this conditional section we have to do some works. First of all, we need to do the adder section. In this adder section we need to add the values. Those adders are two types, full adder and half adder. In this full adder section, this will add total 16 values. That means here we have A and B. We are adding with output C, and C in is the input of value C. In one full adder, S is the sum. Here we have the value A and B. Here we have 0, 0, 0. And then we have 1, 0, 0. Then 0, 1, 0. Then 1, 1, 0. And then 0, 0, 1. Then 1, 0, 1. And then 0, 1, 1. Then 1, 1, 1. That means first value is 0. Then we have, you can write it as like this one, that 0, then 1, then 2, then 3, then 4. Then you can write as 5, then 6, and lastly the 7. After adding those three sections A, B and C in, you can have the output as 0, 0, 0, 1, 0, 1, 1, 1. Here we have 4 zeros and 4 ones, and in the sum section you have also here 4 zeros and 4 ones. S is for the sum section and C is for the carry section. This is carry in and this is carry out. How we generated that? If you get the sum 0 plus 0 plus 0, here carry is 0 and sum is also 0. If you add 1, 0, 0, then it will have the sum 1 and carry is 0. Then 0, 1, 0, it will have the sum 0 and carry 0. If you add 1, 1 and 0, then you will get the sum as 0, and in carry section you will have 1. If you add consecutive 3 ones, then you will have the sum of 0 and sum of carry is 1 here. In this section you have carry is 1 and sum is also 1. In another section you have 1 0 and another one is 1. This is how the full adder works. In this full adder section you have 4 AND gates and finally an OR gate. This is the diagram or formula how to generate the full adding section. Here the formula of generate or calculate the carry is this one. This formula can easily tell what the carry would be. Here x is the value of A, y is the value of B, and z is the value of C in. Now we are in the half adder section. In half adder section we just need two sections. One is x and another one is y. Here we have 0 0 which is 0, 0 1 which is 1, 1 0 for 2, and 1 1 which denotes 3. If you addition 0 0, the sum will be 0 and the carry will be 0. 0 1, the sum will be 1 and the carry will be 0. 1 0 will become sum will be the 1 and carry will be the 0. If you add 1 1, then your sum will be 1 and carry will be also 1. This one is the formula of half adder summation and carry. You can easily try that. In the section of first you have 1 and 1. If you put the value here, the value of x is 0 and y is 1, that's why it will become 0. And in this section the value of x is 1 and y is 0, it will become